Hi, good day to you students. So for today we are coming back to our lesson already. Okay, so for today we are going to cover our chapter 2, right? Okay, then chapter 2 we are going to talk about the logarithmic and also exponential functions. So we talk about the logarithmic function first. Most of you learned it before in SPM. So for those from IGCSE background, I'm not so sure, but I heard that IGCSE actually they didn't cover this part before. I'm not so sure. Okay, I forget, but if I'm not mistaken, I think IGCSE you never learned for this before. All right. So generally for logarithmic function means log function. So for log function, there are some certain numbers that we actually take log to make them become smaller. Okay, and then it has also some other application, like maybe you want to change a curve graph become a straight line equation. You can also use the log function to change the curve become a straight line equation. So there are a few applications for log function. All right, but basically at the first part of this chapter, we are going to learn the basic idea and concept about it. And then you also need to learn how to solve the log equation, the equation with log function, and also after that we need to learn also how to change a curve become a straight line equation, right, by using log. Okay, then exponential function. So exponential functions, anything with power x we call as exponential function. So as an example, if 2 power x, this is one of the exponential expression. Okay, or maybe you are having 3 power x squared. This is also one of the exponential functions. All right, as long as anything with power x, so we call it as exponential functions. All right. Then log, generally you are having LG, or you can see that it's LG. So for those of my SPM background, I think you learned it before, like log 2, log base 2, log base 3, and so on. There are a lot of different base here. Okay, so this is what you have for log and also the exponential function. This is some very, very basic introduction. Okay, then let's start with our detail here. Okay, so maybe for this video, after this video, I hope that you can understand the relationship between the log and also the indices means exponential functions, and also use the law of logarithmic function, excluding change of base. So for those who have idea or who have learned this topic before, you actually learn change of base before, right? But change of base is not included in our A-level syllabus. Totally, they are not asking. So you can just ignore this part for the change of part, right? Okay, so let's start with some very basic introduction first. We talk about the common logarithmic function. Okay, so when we are having the exponential function b power x, okay, and the inverse of the exponential function we call as log to base b, and it is denoted by log to base b, so log b. So which means if let's say you're having the original equation y equals to b power x, okay, you can actually change it become x equals to log by. So these two equations are actually having the same meaning, but this one is in exponential form or indices form, then this one is in logarithmic form. Alright, but these two equations are actually the same, have the same meaning. Alright, so how to change the exponential form become the logarithmic form? Generally, you need to see what do you have as the base. This is the base number. So to change it become the log form, what are you going to do is that you bring the base over and it will become log to base b. And then y you just copy. And the original power, okay, you pull it down, become a number, which is the x. So these two are actually having the same meaning. These two equations are having the same meaning. Alright, so as an example, maybe I give you y equals to 2 power x. Okay, so how can you change it become the logarithmic function? So it will become generally 2y equals to x. Okay, or maybe we take another example. Let's say I'm having 8 equals to 2 power x, and if I want to know what is the x here, what are you going to do is like the 2, you bring it over, become log base 2, and then 8 equals to x. Alright, so you need to know how to change the exponential function become the log function. That's the very first part that you need to know. Okay, and after that, if you look at the domain here, please take note of this domain. Y must be greater than 0. So that means the value y here. That means that all the value, okay, inside the log function, this value must be always positive. Okay, if you don't believe, you can maybe press calculator lah. Log 3, you'll get the answer. But if you want to press log bracket -3, you'll get the error. So which means that the function is only defined for the domain y greater than 0. This is very important, so make sure you remember it. Alright, okay, so this is something that you need to know. Very, very basic. Right, very, very basic, and then try to understand the relationship between the exponential and also the log. Alright, so there are actually the inverse function for each other. Okay, then if we proceed further, okay, so there are some results that you need to know. First one, when you're having log base b, no matter what's the value of b, as long as you're having log 1, the value and the answer is always equal to 0. Why is it always equals to 0? The meaning is because of if you change it back, become the exponential function, then you will see it. Alright, so b is the base, right? You bring it over. So 1 will remain. B, when you bring it over, you become base of b, and then the 0 will become the power. So any power, any value power 0 is always equals to 1. So it is also true for the log function like this. Okay, and then when you're having log b, b equals to 1. What does it mean? And how can we get this result? So again, the base b here, you over, it will become b equals to b power 1. So this equation is easier to understand, right? Therefore, when you change it to become the log function, it will become something like this. So log b equals to 1. As an example, if let's say you are having log 10, it is equals to 1. If you are having log base 3, it is also equals to 1. Okay, so b can be any number and it must be positive, right? Okay, then what happened to this one? So again, if let's say b, when you bring it over, it will become b power n equals to b power n. Alright, so the original equation comes from this, and then when you the b over become the log function, and therefore your logarithmic function will look something like this. Okay, and there's one more important result that you need to know here is actually for the n here, when you are taking log, right, you can put it in front. We'll learn about the properties of log later. Okay, then you'll see that. Alright, so you can bring it in front. If not, then you just assume that, okay, change it become the indices, and then you can compare them. Alright, okay, so this is what we have here. And for the last one, log b log b power n, b power log b n, it is equals to n. So how can we get this result? Okay, so this is actually the indices function of exponential function. Alright, so for exponential function, if you change it become log, that means the b here, you want to bring it over, become the base, right? So what do you have? You're having log b power n on the right, and the original power, you bring it down, become the number. So you're having log b, and so they're actually the same for log function, but if you change it become the indices, it will look something like this. And this result is quite useful. You might need it in later. Okay, maybe later in chapter 5, integration and so on. Alright, so these are the important rules you need to know. Okay, so maybe I give you another example for part D. Okay, let's say I'm having 10 log 10 3. Then you'll get the answer equals to 3. Okay, or maybe you're having 2 log 2 5. So the answer that you get should be a 5. Okay, all right. So all these are very basic for the rules. So make sure that you roughly know how to apply it later. Okay, then besides the basic values here, the basic rules here, you also need to know some basic properties for log. There are a few rules that you need to know. The first one is power rule. Okay, so for power rule means that for any the power, right, like log x power n, log x power something, the n, put it in front. All right, the n you can actually put it in front and you can write it become n log x. Yeah. So this is what we need to you need to know for the first rule here. Okay. Then for the n root rule, n root rule is when you're having log n root of x, then generally you put it into the power first. All right. So you're having the n root of x. So you can rewrite it become log x power 1 over n. And again, you apply the rule that we learned just now, the power rule. The power you can put it in front, and it will become 1 over n log x. Okay, then for multiplication rule, when you're having log p multiply with q, you can split it become log p plus log q. So as an example, if let's say I'm having log 4x, you can actually write it become log 4 plus log x. Okay, so besides this one, you also need to know how to do it in the opposite way. As an example, if they give you log x plus maybe 2 as an example. Okay, log x got x got log, sorry, 2 has no log. So when you want to combine them, what you need to do is that you have to change it become everything got log. Okay, I assume that the log here is base 10. I didn't write, okay, but I assume that all the log here are base 10. Therefore, you're having 2 log 10. Log 10 equals to 1. You learned it before, right? Log BB equals to 1. Okay, so I hope that you can see it from here. Therefore, log 10 is equal to 1. So 2 times 1, you get a 2. And the 2 is a number, you can bring it over, become the power. And therefore, you're having log x plus log 10 power 2. And it is log x plus log 10 squared. So you can multiply them together, it will become x multiplied with 10 squared. And if you further simplify it, it will become 100x. Log bracket 100x. So here, actually, all the steps here involve a few important rules that we learned just now and also here. Okay, you have to know how to use all these rules in both ways. Besides splitting them, you also need to know how to combine it. Okay, so this is the multiplication rule. And after that, when you go for division rule, you'll see that log p over q equals to log p minus log q. Okay, so if you want, maybe I can show you another example here. If I'm having something like this. Okay, so let's say I'm having log x power negative 2. Alright, so how can you split it become 2 log? So log x power negative 2, you can write it become log 1 divided by x power 2. And then you can write it become log 1 minus log x squared. And after that, log 1, you get a 0. The 2 you can bring in front become negative 2 log x. So you have negative 2 log x. Okay, but this one is a long method. The shorter one, you can straight away apply the power, you can put it in front. And straight away you will get negative 2 log x. But now I just want to show you how to use the division rule if you want. Okay, so all these rules, again, you need to know how to apply in both ways. Make sure that you know how to do it in both ways. Either you split it or either you combine it. Okay, they are actually the same. Alright, Okay, so if no problem, then maybe you can have a try. For example one. Example one is they want you to expand the action into all log function. Okay, and you can try example two also, where they actually want you to combine them, become one single log. Okay, so for those who are graduate from SPM, you can straight away proceed with it, and then you just double check your final answer. Okay, then for those who are from IGCSE background, maybe you can follow the video here, okay, to see whether you understand fully or not all the rules. Yeah, all right. So I will start discussing example one now. Okay, so for those who learn it before, you can just skip. It doesn't matter, right? You just double check the answer. Okay, so maybe for example one, let's start. So for example one, they want to expand all the log. Okay, so to expand all the log, first you look at this one, it is a fraction, a log, and then with a fraction. Therefore, you need to split it first. So it will become log QR power 7 minus log PS. Alright, so this is the division rule that you learned before. You split them, become log P minus log Q. Okay, then after that, if you look further into this bracket form, okay, so they are actually multiplication. So you can use multiplication rule, which means that it is actually log Q plus log R power 7. And then because of the 7 is a power, right, I want to apply the power rule, which means that I can pull the 7 in front. So it will become 7 log R, then minus log P plus log S. So the whole thing log P plus log S is under the minus one. Okay, then if you express it and simplify it in detail, then you have 7 log R minus log P minus log S. Okay, so this is what we have for our answer. This is how you actually expand everything in detail. Okay, so in exam, if they ask you to do so, you don't need to show so detailed. You can try to find the answer. Okay, so I show it to you in detail so that you roughly know what are the rules that I'm applying. Okay, then now you go to example 1b. Okay, so for example 1b again, you're having log with a square root of the whole thing. So what am I going to do now is that I need to make the power, the square root into the power first. Hey, sorry, power square root is power half. Okay, so there are a few ways that you can do it. The first one is you multiply the half inside first, then only you expand it. Or you can, the second method is you can pull the power in front of the log. So to me, I think pull the power in front of the log is easier. Okay, then now we're having half, and then with the whole thing now. Okay, so you're having a fraction after the log. So for the fraction after the log, you apply division rule. So a power 4b minus log 3c power 3. Alright, and after that, what else do I have? Okay, so maybe I write it here. So I'm having half, and then expand this one, it will become 4 log a plus log multiplication rule minus log 3 minus 3 log c. Okay, so here I skip some steps. So you're having 3 log c. Then if you want, you can multiply the half into the every single term here, then it will become 2 log a plus half log b minus half log 3 minus 3 over 2 log c. Alright, so this is how we actually expand the expression into a few logs, a few logs function. Okay, so by applying the rules that we learned just now. Okay, all the rules that we learned just now. So hopefully you roughly have an idea actually how we combine it and how we expand it. So this is expand. So now we can have a look for example 2. So for example 2, they want us to what should I say? They actually want us to combine. Yeah, sorry, combine. Okay, so maybe I put it here. Okay, so how to combine everything here? So to combine all the equation, right, all the log function, what you need to do is like you have to make sure every single term also got log. That's the first thing. And the second thing is you have to make sure that all the number in front, you have to pull it back, become power first. Okay, so let us check. So first term, 2 log A. So to combine them, before you combine them, you can actually change it become log A power 2. Okay, second term, half log B. So to combine them, what you need to do is like, you put it as log B first, and then you bring the power, bring the number back, become power. Okay, then the third term, negative 2. So negative 2, generally you don't have log, right? So you have to create a log for it. So how to create a log for it? So you assume that this number at the back is 1. How to get the 1? So it is log 10, 10. So we assume that all the log here are base 10. Okay? And after that, again, the third term, what you need to do is like, you can move the 2, become power. So you become 10 power 2. Alright, so now you double check again. All the every single term here already have a log, and all the number in front you already pull it back, become the power. Then now you can start combining all of them. So you combine everything here, all the log here become 1 log only. Okay, if let's say in front of every single term is plus, then you put it on top of the denominator of the fraction. That means it is the numerator. If you're having negative in front of the term, that means this value will be the denominator of the fraction. So if let's say I combine all this together, I'm having a squared b power half divided by 100. Divided, why is it divided? Because of negative. Therefore, it should be the denominator. Alright. Okay, so I hope that you roughly have the idea of how you actually apply the rule. When you put the minus under the denominator, it is actually the division rule, but we just do it in the other way, in the opposite way. Alright. Okay, so this is what we have for example 2. And now let's continue with 2b. Okay, so how to solve 2b here? Right, so for 2b, okay, maybe if let's say you already have the idea already, then you can do it yourself. Okay, for those who still not so sure, maybe you can go through this example, right, my steps here. So again, I want to move all the number back, become the power first. So first, I'm having log 2 power 3 plus log 5 power 3 minus log 10 power 6. Okay, and after that, everything here already got log, and then I will combine all of them, become one single log, one log only, and then I'm having a fraction. So first I'm having 2 power 3 multiplied with 5 power 3 divided by 10 power 6. Okay, so after you combine them, maybe you can double check and see whether can you further simplify it or not. Alright, so 2 power 3 multiplied with 5 power 3 divided by 10 power 6. If let's say I don't want to use calculator to do it, I can actually make it become 10 power 3 divided by 10 power 6. Okay, so the rule here is, I forget what's the rule already, that we learned in chapter 0 in AS level, paper 1. Okay, so it is the indices rule. Alright, so you can pull the power 3 out of 2 and 5, so 2 and multiply with 5 together become 10, so it will become 10 power 3. Then again, if you continue further, when you want to simplify, this will become 10 power negative 3. And again, if you pull the negative 3 in front, then it will become negative 3. Because log base 10, 10 equals to 1. And your final answer for part B should be negative 3. Okay, so this is what we have for our log function. Alright, so for all the log function here, generally, when I didn't write any number here for the node, we actually assume that it's log base 10. And then for general one, you will see that most of the people will write it as LG. LG also means that log base 10. Okay, so for all the example here, all the log here, I assume that it is log base 10. Alright. Okay, so this is what we have and how we apply the logarithmic properties, okay, in expand them and also in combining them. Alright, so for the next part, only we are going to continue to learn another new base, which is log base E, and we call it as natural log. Right, so it will cover in the next video.